People.
Oh, we already have
Yes.
50 people. Yeah, that's good.
Yes, sir. And some are on YouTube also. They are watching live, sir. Yeah.
Okay, great.
So we shall start the session. So greetings to all our dear participants. I welcome you to the 7th day of IEEE Virtual Talk series, which is focused on photonics and optical technologies. And I welcome to grace today's occasion, we have with us our IEEE Student Branch Counselor, Dr. H.K. Sardana, sir, Chief Scientist at CSIR-CSIO. So I formally asked sir to give his opening remarks and welcome address. Over to you.
Good evening to the Indian community of professionals, and of course, good morning to our honorable, beloved speaker of the day. It's really nice that the student chapter has been celebrating so many activities in the last week on photonics and optical technologies, particularly to celebrate the International Day of Light. So I'm wondering that although I had no particular time to interact with the speaker earlier on what he is planning to talk, but I wonder, I'm looking forward to rather a lot of opportunities that he has planned for, or rather expecting that India can take advantage of. And these come without challenges. So we already have the worldwide challenge with us before us. And in this situation, this particular topic for an organization like ours, which is already multidisciplinary and interdisciplinary in nature, and country as a whole, which is also undergoing all kind of variations and major changes, and also bringing, CSR particularly coming closer to the industry. So I'm wondering that while this area of photonics and optical technologies can have a lot of opportunities, as I envisage, in communication, strategic electronics, and defense and societal applications. I hope these things would emerge during his talk. And also, as a country, how are Indians, finding this subject matter, both as professionals and also as community or as consumers? And I'm rather putting these questions beforehand. I'm rather very eager and keen to listen to him on what kind of skills and competencies he finds from this country while he is planning to share some possible opportunities. And also, how is the individual and industry working in this country, uh, or what would be the opportunities in terms of import versus export? And also, at least we find sometimes the scales of operations, not coming to the level of population that we have, or the industrialization required in the country has to see probably a lot of changes. And probably sometimes we consider as if the ecosystem is not into, into favorite kind of environment. So what does he see? What do you see from a place, a developed nation, and also with the origins of this country? It's very nice that you agreed and are now willing to share your perspectives on this great expertise that you have already gained, and using that expertise, how you can guide this younger community who is joined by, to watch your, to observe and to listen to your views. So what do you perceive? How do you see India can see opportunities and challenges in this area of photonics and optical technologies as a big nation with varied expertise and varied expectations? I'm really excited to look forward to listening your views and also the interactions and deliberations that emerge during and after your presentation. So thank you and welcome once again each one of you who is joined for this virtual talk. And we request Anupama to share a brief about her, about his background, and then we are all excited to listen to him. Thank you
Yes,
very
sir.
much, and all welcome once again.
Yeah, thank you so much, sir, for your opening remarks. So it's my privilege to formally welcome our speaker and introduce our speaker to all of you. So present Dr. Dr. Naresh Chand sir is representing IEEE Photonics Society in multiple voluntary capacities. Recently, he has got retired from US R&D Center of Hawaii Technologies in New Jersey, where he was working low-cost advanced technologies for ultra-broadband optical access networks since 2011. Prior to this, sir has worked for BAE Systems from 2003 to 2011 and at AcSIR Systems and ANT Lucent Bell Technology and Laboratory from 1986 to 2003. And he has also worked at Department of Electronics, Government of India from 1974 to 1979. And he was involved for licensing and developing optical components for industry. And if we look into the research areas of Sir, so he's mainly focused on optical communication systems, fiber to home, RF over fibers, high power 980 InGaN arsenide pump lasers, HBTs, HEMTs, QWIPs, gallium arsenide, silicon based systems, and molecular beam epitaxy. And he has several first and various world records to his credit. And he has authored more than 1 publications and 15 patents have been issued to his credit. And he has did his MSc Electronics in 1974 from BITS Pilani, and on a British Commonwealth scholarship, he had done his Master of Engineering in 1980 and PhD in 1983 in Electrical Engineering from University of Sheffield, UK. He has also worked as postdoctoral fellow for two years at University of Illinois at Urbana. So with this brief intro, I welcome you, sir, for your talk. Over to you, sir.
Thank you. Thank you, Professor Saldana and Ms. Thakur. I really appreciate that you have invited me today to join your series. It is a privilege for me to talk to the young people because you are the future. You know, we look forward towards you. You know, I have 5 grandkids, and I'm learning from them. Sometimes I teach them, give them remote classes, but at the end, I find that I end up learning from them. Professor Sadana, the question you have asked, they are very relevant questions, and I would address them in my presentation. And these are the questions I asked myself, but at the same time, please recognize that I'm away from India for last 40 years. But because I used to work for Government of India, so I had the opportunity to visit all the industries in India, and so I had that idea what what the situation. Last year I traveled to a few institutes in India, to Guwahati, in Kerala, and I met quite a few students and talked to them. I gathered some information from them, and I have a keen interest to see what's happening in India. So based on that, I have put this presentation together, Photonics Opportunities and Challenges in India. Now, as Anupmaji told that I represent Photonics IEEE, in different voluntary capacity. So these views I'm going to present are my own. They have nothing to do with IEEE. IEEE does not own any responsibility, so that should be recognized. Now, photonics is playing a big role in our life today, whether it's healthcare, it's communication, economy, environment, or social life, right? This communication has made the world as a small, village, and we're having this meeting because of the communication, which is largely based on photons. Now, the couple of things here, the IEEE today is working for advancing the technology for humanity. The technology by itself does not mean much unless it serves the humanity, and that should be recognized. And we should be thinking about whom I'm helping, what I'm doing when I'm doing some research. Otherwise, the number of dollars are very limited today. Old days are gone that you can do anything you like. When we joined in Bell Labs, we were told that just advance the state of the art. Don't worry about any application or no application. Don't worry about cost. But those days are gone. Everybody, you start something, we ask you, who's your customer? Why are you doing this? What benefits it will bring to the society? Now, IEEE has 38 societies. One of them is IEEE Photonics Society. And the focus of the Photonics Society is to transform science into technology. Now, I noticed that in Chandigarh, you do have the IEEE chapter, but you don't have the Photonics Society chapter. So I strongly recommend you that you form a student chapter. The additional membership you will pay is very little. It's just few dollars per person. But the benefit you would get are enormous. We have given already approved 7 projects, and they mostly went in South Kerala and in Karnataka, ranging $1,500 to $2,500. One thing I'm glad to see in India that the female scientists and engineers, their number has increased significantly. And IEEE is encouraging diversity, supporting the young professionals, women in photonics. And Photonics Society has a lot of money, they have $500,000 allocated for the outreach programs. So my recommendation that please take advantage of that. Now, in India, when I visited a number of places, I saw what was missing. So we had 27 chapters in India of the Photonics Society. And one thing I did was that I had a meeting with all of them, one evening. And we formed this group called Prakash Bharti. Prakash means light, you know that, and Bharti means, is Saraswati or Vani, voice, also, derivative of Bharat. So we created this icon also, and it has a very powerful message. And in this powerful message, actually, answer to many questions are included in there. The top 3 words here, Tattvam Asi, that itself is the subject of at least 1 week of talk by any spiritual teacher. But if you understand this, these are the 3 words, which is the summary of Vedanta. These are the core values of Eastern system of knowledge. But in India, many people do not know about them. But the people in the West, they follow it unknowingly. So in India, we are supposed to be seekers, and people outside India, they are supposed to be believers. But it is happening somewhere the other way, unfortunately, and that is the paradox. Tattvamasi means I am that, what I seek. Means I am the problem, I am the solution. It's not outside me, So it gives you the entire power to you, that you and the Supreme, they are no different. Sky is the limit. So this is what in Western countries, they tell you, hey, sky is your limit. Explore your limit. Do whatever you want to do. So they follow the Indian system, and we Indians follow the Western system in real life. So as an introduction to photonics. So as you all know, you are expert in optics. The light travels as wave, but when it interacts with matter, it behaves like a particle. So it doesn't behave like a particle until it interacts the matter, and that particle is called photon. Optics is to manipulate the light through lenses, mirror, etc. And photonics meant to generate, modulate, sense, and process the photons. A photon has no mass, but it has energy. It travels at the speed of light, and it can carry a lot of information. But the thing is that the photon itself, it does not work in isolation. To generate a photon, you need an electron. To detect a photon, you have to generate an electron, and then you count the electrons. So electronics and photonics, they go together. And photonics is the key enabling technology at the current 4th industrial revolution. We are at the beginning of the 4th industrial revolution, and photonics is playing the key role. Without photonics, nothing can happen. We can't deal with this COVID-19 crisis without photons. So it is playing a vital role in our everyday life. It's everywhere around us, and new technology and applications continue to emerge. We had this CLIO conference 2 weeks ago. There were 18 parallel sessions in some days and lasted for 5 days. So you can see the amount of activity is going on. It's unfortunate that Sadhanaji question you raised, and here is the answer partly here. All the developed countries, they have National Photonics Initiative. In US, it's called now National Quantum Initiative, because photonics and quantum mechanics, they're the same thing. So most countries have the National Photonics Initiative to find the solution to the major social economic challenges. Unfortunately, India does not have. And Indian scientists, senior scientists, I think partly they need to be blamed. And this is my effort to talk to our youth, because they are the future. They have the energy. They have to take initiative. Because do not rely on your advisors. Do not rely on your professors. Do not rely on the policy makers. You are the drivers. You are the crew. You have to think about what's going on in the country. So that's why I'm talking. This is my 4th presentation, and I have already talked to about 500 people. I'm trying to create an awareness, and I'm only relying on your youth and young professionals. Photonics require very little power, so it has a low carbon footprint. It offers big opportunity to India to contribute and benefit. India has 1.3 billion people, right? So it can produce, it can consume, and it can export. And as Professor Sadhanaji was asking that we do not have the level of operation, and that's what we have not realized. We can address both products and services. India, should contribute at least 2 to 5% of the India's, desired 5 trillion economy by 2024. It will create jobs and prosperity. Now, photonics is a multidisciplinary science, right? So it doesn't mean that you have to be a physicist or electrical engineer or a mechanical engineer. It requires people of all background, the chemists, the physicist, the mechanical engineer, the biologist, the physicist. And this century, 21st century, it really belongs to photons. It requires private, public, and foreign investments. But we require drivers. We require some people who can push it. People, the decision maker, they probably are not thinking this is not their priority. Now, the photonics, the global market, in 2018, it was $636 billion. It is expected to reach 1 trillion by 2024, which is about 1% of the global GDP. Okay, so approximately 8% natural annual growth. So if you have 1 trillion expected, contribution to the world GDP, India should have 10% of that, right? India has 17.5% population. And India is a quite advanced country today. So if you have a goal that India should at least contribute 100 billion, to the GDP, then we can reach there, right? Unless we have a goal, right? Prime Minister of India, he has a goal of making the Indian GDP to 5 trillion. And if you, the youth, the young professionals, if you approach your decision maker, hey, photonics has a big potential here to contribute 10% or even more, then people will pay attention. Now, what are the technologies here in this the photonics business? So you see that here, the display is the largest, right? You use the display for your television, for your computer screen, for your phones, information technology, photovoltaics, your production technology, and the production, you are using photonics everywhere. I was in a company, visited a company in Surat, a diamond factory, and they are using the laser beam to cut the diamonds. Defense and security, big requirement, the communication, the lighting, optical components, machine vision. So these are the different applications, and you really have to think, where do you belong here, right? So at your young age, you need to see where you would be after 5 years, 10 years. Technology changing so fast, you just can't be just there. You go to live only once, so explore your full potential. So when I was putting this together, that how could India reach this $100 billion target if we define this target? So I started writing the different fields here, and doing some calculation based on number of population requirement from each family or individual. So I get the number on the right side. So the very first app is photosynthesis to clean the air and beautify our surroundings. And you people could help the poor people, the farmers who are dying, who do not have the cash flow, your maid servant, we talk about it in the next slide. The energy, this is a success story of India, that India has already reached 30 gigawatt power, by in February 2020. They have a goal of 100 gigawatt by 2022. But unfortunately, India is not making the solar cells, right? The panels. They are only buying from China. The communication and information technology, our life now relies on communication, sensing and imaging, the lighting, the display, the healthcare, and this is a big area. Healthcare, photonics is finding application in diagnostics and therapies, gene modification, drug developments, defense and security. India is the largest importer of the defense equipment, and photonics play a big role there. LiDAR, VCSELs. Now your phone, smartphone, the 3D imaging would be using an array of VCSELs 32 by 32, which means 1,000 vertical cavity surface emitting lasers will go in one smartphone. Material processing and low-cost manufacturing, entertainment, food preservation and sanitization by UV light, agri-photonics, the smart farming. 60% of population of India are dedicated to the agriculture industry, and their contribution to GDP is only 15%. Now, this includes even the seller of the vegetables and the fruits, includes everyone, because the agriculture industry is just not the farmers. There are a lot of people who rely on agriculture. So these are the different areas, and I put the numbers together, and it was a coincidence that I put the number, and at the end I added, it turned out to be exactly $100 billion. I did not do any tuning up, but the number has turned out to be exactly like that. So you think about that, go through these applications, what they are, go to Google search, go to IEEE and do some search. What are the applications here? What are the potential benefits for India? Then you will come out with some solution. But as I said, you are the drivers, you are the crew on planet Earth. Don't rely on anybody else, your advisor, your supervisor. They actually should depend on you, your advice. You are the fresh blood. So you take the responsibility and do your homework and come out and you decide what you want to do and what you think is the future. So I told you that this CLIO 2 weeks ago, it was held for 5 days, multiple parallel sessions. These are the different areas discussed there, that what are the things. And you may find that that in India, there's activity in every field, silicon photonics, integrated photonics for neural networks and neuromorphic computing, quantum photonics, nanophotonics, nonlinear optics, UV, near, mid-infrared sources and detector. The number 7 items here is very important for India for research as well as applications for defense everywhere, UV, near, and mid-infrared sources and detectors. Microwave photonics signal processing, this is for defense. Terahertz photonics, flexible display, this is a disruptive technology. This will bring a new revolution. Optics and photonics for precision agriculture, artificial intelligence and photonics imaging and sensing, free space optical communication, imaging, sensing. So these are the CLIO conference is recorded. Since you are at home, this lockdown period, go and see and see what's happening in the world. One thing you would notice that when you go through the program of CLIO, that most of the work is done in universities, not in industry anymore, because the industry does not have the dollars. China has killed most of the industry outside China because the low cost. We'll talk about it a little later. So the next slide. In China, in the month of September, first week of September, this is the largest show, expo in Shenzhen. It's like a city, I've been there a few times. So there are different pavilions there. And I have sent you, by the way, this presentation. Anupma, you feel free to share with anyone who has any interest. And there are different pavilion, and it shows you. Sorry, I can't hear you. You said something?
No, sir. I said, okay, sir, I'll share. Yes,
Okay,
sir.
okay, good. Thank you. So you see the different areas here, different products there. If you happen to be in China or Hong Kong, Shenzhen is and Hong Kong, they are just like Ghaziabad and Delhi, just a river in between. But it's a wonderful place, wonderful city. All your smartphones are made there. But I would draw your attention to the last one, the innovation pavilion, right? That's relevant to you researchers, right? If you think here that major efforts here is biophotonics, medical imaging, healthcare photonics, the smart healthcare. I mean, this is one area in India. This healthcare cost is huge, and same thing here in US. Most of the people like us, we work all our life, we save money, and turn out that most of the money will be used for the healthcare. If we end up in the hospital or nursing home, that's where the money would go. So you go to any doctor, first thing they will go and do these tests, and cost a lot of money. And photonics can play a big role here. So these are the areas which are where people are working, where for research, these are the good areas. So today, this is photosynthesis. Out of 25, 15 most polluted cities are in India. And you know it, you don't need any introduction of that. Our body, probably you might not know it, because I myself came to know very recently, our body needs 7 to 8 liters of air per minute, not per hour, 7 to 8 liters per minute. So we need to inhale good air, and so we need to purify the air, otherwise we cannot live healthy. And photosynthesis is one thing which could be used, to convert the carbon dioxide, to oxygen requires sunlight. So I would ask every one of you, while you are at home, plant some trees or shrubs. At one time I was in between jobs. I planted some 350 trees and shrubs, around my house. So you see this this picture here. I planted all of them with my own hand. I planted like 350 trees and shrubs. This is backyard of my house. And you see the front, this is the front of my house. I also have the solar panel on my roof. I generate my old power, 5 kilowatt system I have here. I already recovered my cost. If you have inside, indoor, you could have, this is inside my kitchen. And on the roof, I had this hanger and the 4 planters here. So if you find that in your living room, you can put some plants like this. If you find that there is no room outside the window, you can have these planters made here and plant some trees and shrubs. You can put on your roof. So this is what, and you could advise your maidservant, your farmers, that they could have a small nursery, in their farm or in their backyard. I come from a village, and in the village, many people, their main source of living was taking care of a buffalo and selling the milk. Now, if those people could be advised that they could also have a nursery and have like 100 of these planters and plants there and sell them, and you people could advise them that which plant are more efficiently convert, carbon dioxide into oxygen, require least amount of water and all that. So you can make a big difference in the life of the poor people and the farmers who are the backbone of the country. Now, this chart, if you do any management course, any marketing course, first thing they will introduce you to this chart, because this chart is based on needs and wants of everyone. And we have the basic need, food, shelter, water. Then you have the safety and security, and then you have the lung and belongingness and self-esteem, self-actualization, and you can translate them to artha, kama, dharma, moksha. And based on that, that's what the company, they exploit the needs, right, to come out with new products, new ideas, right? But today, a new need has come, and that is the need for the broadband connectivity. And photonics is the key enabler. So anywhere you go, and if you don't have broadband connectivity, if you don't have Wi-Fi, if you don't have the network coverage, you don't feel at ease. So photonics is playing a big role here, right? So this is what now this COVID-19 has shown, that this has become a necessity for everyone, because it will not go away. The COVID-19 would stay for some time, and we would be working from home, distance learning, we would have meeting like that. So the broadband connectivity has become a necessity. In US, the cities which have the broadband network, like fiber to the home, the property values goes up by 10%. People like to do business there. The factories, the businesses, they like to locate there. So this has become like a super highway. You know, you would like to go to a city where you have the infrastructure. So this broadband connectivity has become like that. I mentioned to you that we are at the beginning of the fourth industrial revolution. And this is really the fusion of different technologies together to make everything smart, you know, and reconfigurable. And photonics here is again the core enabling technology. The first industrial revolution was when the steam engine was invented in 1765. Second one was, you know, this period of like 44 years when the steel, you know, steel industry developed, phone came, mass production, the light bulb. And third one was when the ICs were invented, the PCs, the internet and digital age in 1970s. And today we have this beginning of the fourth industrial revolution, the fusion of technology, which includes on the left side, this box has the enabling technology, 4G, 5G wireless, broadband wired access network, big data and deep learning, machine learning, clouds and data centers, fast processors, sensors, MIMO, optical interconnect, software-centric defined system network. And by the way, Indians have played a big role here, not in India, but outside India. You will go. My daughter works for, one daughter works for Google, other one for Microsoft. And when I visit them, I find that we go to the cafeteria full of Indians. You know, Microsoft is run by Indian, IBM is run by Indian, Google is run by an Indian. So the Indians had done extremely well in this area, right? And these enabling technology, they lead to artificial intelligence, robotics, drones, virtual reality, augmented reality, autonomous vehicles, wearables, IoT. And that leads to smart cities, smart villages, streets, section enterprises, homes, smart living. And all these really require, you know, broadband connectivity, wired and wireless. If you have the data center cloud, you require optical interconnects. Now, the question you would ask that, hey, how come Indians are doing so well outside and not in India? The answer is the logo of Prakash Bharati, Tatvamasi, because these people here in outside India, they have the ownership, they have the responsibility to do the things, and the ownership in India is, I feel, this is my observation, is missing. For every little thing, you need several approvals, several signatures, and people lack confidence. They would ask advice or, you know, orders from their bosses. Over here is the other way. When I joined Bell Labs, I went to my department head for some advice, but he was angry with me. He said he hired me to give him advice. He said he hired me because he thought I am an expert in my area. So he said that he depends on me. I should not depend on him. I should tell him what needs to be done, how it needs to be done. And he is also my mentor. He is the inventor of molecular beam epitaxy, Dr. A.Y. Cho. He told me that never go with a problem to your boss unless you have a solution. Always go with the recommendation, always go with solution. And solution will come if you have a problem and you think about it. And most of the time solutions come not when you want them to come. They come normally when you are early morning, you are in the bathroom, you are taking a shower, your head is clean, your heart is clean, and you may find that. But if the problem is in your head, then solution would jump in. Or in the early morning when you can't sleep, then you find that solution will come. Just for your information, when we go to temple, when we do meditation, or we go to church or mosque, and we do prayer, the purpose of prayer essentially is Atam Shuddhikaran, purify your system. And when you purify your system, then good thoughts come in and the solution comes in. So that's how the prayer works in. Not that the God is listening to you, or it is a process of Atam Shuddhikaran, self-purification. And when you are purified, then good thoughts will come. So always think about, you take the ownership, you decide what India needs, how we proceed, what resources we need, where are those resources. Don't depend on your boss, don't depend on your advisor all the time. You become the advisor, you become the driver. That's my message. That's what I found. I mean, back home when I was working for Government of India, even for 5 rupees investment, if I had to spend 5 rupees somewhere, I need an approval. Over here, I had the power in Bell Labs that I could place an order up to $1,000 each time without any signature or anything. So they give you credit card, buy anything you need. So those are the differences. Now, one thing people ask always, what's the next big thing? This is what people would ask. All the investors, everybody would ask, what is the next big thing? Where should I invest? What should I be working? So today, the next big thing people are talking about applied artificial intelligence. So universities here in US, they have started offering the master course. I am an advisory board of the Stephen Institute of Technology, and went to their annual meeting, and they told that they just introduced this course, artificial intelligence. And this is to develop the strong background in understanding the theoretical foundation of artificial intelligence and deep learning. And there also, like if you are doing MSc Physics, you have choice of specialization in nuclear physics, in optics, in electronics, or any other field. So there they had to pick up, the specialization. You want to work in intelligent communication network, autonomous robotics, image processing. So these are the different applications, right? And artificial intelligence for photonics, imaging and sensing. Imaging and sensing, they play a big role. And last night when I was talking to Mr. Jain and Anupma, I learned that you guys are working in imaging and sensing, so you are in the right area. Try to explore applications of that. Just don't work on imaging and sensing some theoretical aspect. Make some prototype, develop something, and give life to it. Now, one application which I think that could have a big potential in India, maybe all over the world, is design a divine robot. This would be, cool applications, because each family, Indian family, no matter where you go, they have a family, they have a temple at home, they have a different, the statue, the idols, and all that stuff, right? And everyone has their own god and goddesses. So if you could design a divine robot, who stays at your home, who has the brain, who can listen to you, who can listen to all conversation, and if you need an advice, this fellow has access to all the world resources, and you can ask any information, and it will help you. If the spouses have an argument, or children and parents have an argument, then this fellow is listening. He can jump in. Hey, he can act like a grandfather or grandmother. So think about that. I mean, this is something people have already started working on it. But if you can make it reconfigurable, that you can invoke the presence of Lord Rama, Lord Krishna, or Buddha, or Mahavir, or Guru Gobind Singh Ji, anyone. So think about that part. This is something that it could create a huge market, because when you bring idol, like this thing, Ganesh Chaturthi, if you go to Maharashtra, then the Ganesh is a big thing. So if you can make Ganesha, a divine Ganesha, where the Ganesha is just not only made of clay or stone, a real Ganesha, which I feel that it could have a big market and requirement. So each of my slide itself is a topic of at least 2-3 hours talk. So I'm just exposing you to different technologies, what are the different things happening in the world today. So this is my area of specialization, the network. By the way, you are young people. Do not have any limitations for yourself. You people can do anything you want. You decide what you want to do, and see The golden rule is that decide what you want to do and then figure it out who has value for it and then make them pay for it. That's how it is. Many times you feel that, oh, I don't have money, I don't have resources, I don't know what to do. So you think about that. So my first degree was MSc Physics, but then I figured it out. There were no jobs there. I did MSc Physics from Merit University, a small college, and but then I felt that, hey, this is not the right thing for me. I changed to engineering. I went to Planning, did Master of Science in Engineering in Electronics. Joined Government of India. I worked on materials and devices for 18 years of my life. And then I felt that, hey, I'm going to live only once. And material devices is at the bottom of the food chain. And I felt it requires a lot of hard work and the credit takes mostly system people. Then I switched to systems. Bell Laboratories at the time, they were putting a system together for a department together for fiber to the home and looking for volunteers to join. And I took the advantage and joined that. So I changed my field. For last 22 years, I've been working in optical communication systems. So you can do anything you like, decide which application you want to be in. Now, this is the network classifications, what are the different networks, and the meeting which we have, try to figure it out, how does it work. So most of them is based on optical fiber. So the first network is submarine cable network, undersea cable. So you have the optical fiber on the seabed. So I'm sitting here in New York, and the optical fiber goes all the way to Europe and the Suez Canal, and it comes to here in Bombay or in Chennai, and from Bombay. So this is called submarine cable network. There are special ships which deploy the fiber on the seabed, and these cables are very thick. It carries not only the optical fiber, it also carries the repeaters, right? And that requires power. So it's a power cable and all that. And they are very specialized cables because they have to make it shark proof. Shark does not eat and bite, And there are different, like you have highways, national highways, so and so. So each network also has a name, for itself. So this is called submarine cable network. So earlier, in 80s, 70s, 60s, it was all through satellite. And that's why the phone was quite expensive, phone calls. But today, because it's optical cable and like huge capacity, so the voice or video calls are free. Like we are doing this is free. So from Bombay, then it has to connect to Chandigarh. And that is called long haul network, city to city. So here at the bottom, so if this node here is in Bombay and this node is in Chandigarh, so this connection here is called long haul network, city to city. It's called backbone network and goes by different name. And then in the city, like in Bombay, in Calcutta or in Chandigarh, then you have a ring here. The fiber, traffic goes in both directions so that if there's a cut here, then you are not affected. Traffic can move in the other direction. So this is called a metro network or metro ring. So in Chandigarh, you may have something similar to that. Now, in the city, you may find that there are different central offices. And these central offices, they are connected to the end user. And central office connected to the end user, that is called access network. And so you only deal with access network. You don't deal with this. This is embedded, deep in the network. And if this here is the node there somewhere, central office, and here this one fiber is coming here, and you have an optical splitter, and then the fiber comes there and connect to the individual offices or home. This is called, a wired access network. Or you could have big enterprises like Bharat Electronics or Indian Railways or the defense services. They may have a dedicated fiber and they have their own network, right? Like airport, they may have their own network, and that's called enterprise network. So that is enterprise network. Then inside, like you have a campus in CSIO, and inside you have network that's called local area network. And that at your home, you may have their own personal area network, your computers, your multiple computers, your router or switch that are connected, that's personal area network. And if you are working in the sensor, getting the data, and feeding somewhere, that's sensor network. Now, this is what the system consists of. It's called OSI, Open System Interface model. There are 7 layers here. and the bottom is physical layer. So most of us, I work in the physical layer, which is, physical, you connect either fiber or electrical wire. If you are dealing with switches, a switch level, the switch and has only the physical and data link to functionality, and this is all hardware. And router is, half network and half hardware. So most of that stuff is software here, right? So Indians have done extremely good job here in the software business, and Chinese had done extremely good job in the hardware. So all your the hardware stuff is done in China today, and that has become a problem. Professor Sadana, you asked a question, and that why we are not doing well is because China can produce everything at very low cost, and the productivity is pretty high. And so the lot of industry in the West, whether it is Europe or in US, or in India, has died because China has provided the low cost stuff. But engineers are needed to maintain all these networks here. Now, this is a brief exposure to the network, how the things work, right? How we are having this this video meeting. And this is the access network, and this is what I was doing. This is the access broadband access network for last 8 years. So this is called OLT, optical line termination, and this goes somewhere here in this node here, a central office. And each port here, it's collect to the end user, right? And here in the center, these two ports, they connect to the metro ring, the core network. So inside this box is a switch fabric. So when you want to connect to me or anywhere else, all the switching take place inside this box, decides where it has to go. Now, each port here comes one fiber, and that fiber here is actually, these are the different generation of the access network, GPON, that is gigabit passive optical network. When you have fiber to the home, is all passive. Passive means no electrical power needed anywhere. So gigabit PON, gigabit passive optical network. Then this is the next generation. X means 10. This is this thing, Greek word, let XGPON, 10 gigabit per second data rate. And TWDM means here 4 wavelengths go there. But India is deploying only GPON. And this fiber comes here, and this is called optical distribution network. It's all passive. No power is needed anywhere here, just optical fiber. And then you put here a splitter, 1x16, 1x32, 64, or 1x2, and a fiber can go to end user home or gram panchayat or any office, and this is all fiber to the home, or it could terminate at the curbside, that is called fiber to the X. And from there, you will see a box there, and from the box, the optical signal will be converted to electrical signal, and this electrical signal will go on your twisted copper wire, the existing your line you have your home. And this is called DSL. And here the traffic is got aggregated, and then it goes on the optical fiber. And then another method is coax, coaxial line, which is meant for the video network. And here all the data here, it get the RF subcarriers, they get modulated with this data, and the data goes here as RF subcarriers. So here, the data, there are two kinds of technology called baseband and passband. Baseband is when you are transmitting 0 and 1s, or the signal as it is generated. And passband is one when you put the data on RF subcarriers. And that is like if you are radio, you are getting signal from Vivid Bharati or All India Radio, and that is a passband signal because signal coming on RF carriers. Or if you are getting from satellite, that is also RF carriers. So that is passband signal. So this signal here is the passband signal. You are getting the RF signal, and then you have to do the demodulation and all that. And here, when you have fiber, you don't need any demodulation. You are already getting 1 and 0 here. You require no power. So you think about that if you want to have support a network, want to build in greenfield. Greenfield means when there is no network there. So this is the cheapest because fiber costs very little. You people do not know, but at my time in India, People used to steal the telephone wire. They will cut at night time and cut the telephone wire and sell, and people have no connectivity. But the fiber, if you cut it, it has no value. So this is more safer, right? And it's very inexpensive. It requires very little power and no power here. But if you want to have the copper or the coaxial line, the network operator, they had to have a power generator here, a standby power generator. If there's a power failure, your network should not fail. It's quite expensive. You require real estate here. You require maintenance people there here. So these old technology, copper and coax, they're very difficult to maintain, require, it's called OPEX and CAPEX. OPEX means operating cost and CAPEX means capital expenditure. So for the green field, the fiber, this is the simplest solution. The other one is that you have the Wi-Fi. It's called hotspot, public Wi-Fi. By the way, and what fiber can also connect to your cell tower. Cell tower, you may be operating, your Wi-Fi or your connectivity to the cell tower, but cell tower has to be connected to the network, and that is called backhauling. And it could have a point-to-point connection. This guy can be connected directly to the central office, or one of the fiber can connect to that. That's called backhauling. And in India, old days, if you have poor connectivity, and maybe the backhauling is through the microwave connectivity, that you have some microwave. This guy is connected to another tower, through microwave. So, but right now, what happened that the data requirement has gone up. When you had LTE, LTE is 4G, that you had to have fiber coming here. So, that's how the access network works. And on the left side now, if you come back here, by 2025, some 820 million users are expected. And it's to expect AAA service anyway, anywhere, anytime. This is already happening. Anumaji is sitting in Shimla. Some people of you are sitting in Chandigarh. I'm here in New Jersey. So, and you can have connectivity through phone, your cell phone or your computer. And this fiber to the home in India today, you only have 1.3 million lines, as opposed to 350 lines in China. See the difference. So a lot of people brag that we are this, we are that, but we are so backward. I hear that Bharat Fiber, which is a spin-off of BSNL, and Jio Fiber, they are deploying fiber. Unfortunately, the cost in the world is highest in India. I'm told it is $1,580, per line, as opposed to $200 in China. It's $500 in US. I hear that India has plans to connect every village, but now because of the COVID-19, I think everybody would like to have connectivity, through fiber, because everybody now needs the bandwidth. This thing is not going to go away, and a lot of people would be working from home. So I already told you that both copper and coaxial line fiber, they will coexist. The wireless technologies are LTE Advanced, and Wi-Fi and 5G, right, fixed and mobile. So the buzzword today is called convergence of all the technologies, wired and wireless. So you find that you may think that you are at your home. If you have Wi-Fi, your phone will automatically connect to the Wi-Fi. If Wi-Fi is not there, it connects to the cell tower, right? So you have convergence of wired and wireless network. In old days, the voice network was different. Your telephone provider was different. The video was different, right? Your data. So the computer, your telephone, your TV, they were connected to the different providers. You needed, a different service provider. But now everything is bits, right? In the digital world, they all are together. They share the same network, same path. So it's called convergence. And through this, you can also have quality of service. You can have bandwidth allocation. You can allocate whatever bandwidth you pay, and you have virtual LAN. Virtual LAN means that you can have a part of the network just serving you, not anybody else. India has announced 99 smart cities, and these are the first 20 smart cities of India. And all of that, you cannot have smart cities until you have a broadband network there. Because smart city means that you need to have a connectivity. And for the connectivity, you need to have the broadband, and applications of smart city are humongous, right? You can see that um, anything, consumer benefit, improve welfare, increase innovation, productivity, GDP, new jobs. And these are the 100 of new applications here, but they require all broadband connectivity. So India, I think now probably would realize that decision maker, that time that the broadband connectivity is available everywhere. Now, many of you are working on sensors, but sensor itself is no use unless you make use of that. So you need to get the data out of that. So if you are in the university or CSIO, try to develop a prototype, make a little box, have a little power supply there, and, buy data acquisition board. And there are different wireless technologies here: Bluetooth, Zigbee, G-Wave, Wi-Fi, LTE. This LTE is unlicensed. It doesn't require a license. So there are different advantages and applications. I have a smart bulb at my home. With voice activity, I can turn it off or off. With my phone, I can turn it off and on from anywhere in the world. And that use Bluetooth, Wi-Fi. If you have temperature sensor outside that use, Zigbee or Z-Wave, Bluetooth. If you have automatic, car, the door opener that use Bluetooth. So these are different technologies, and try to, you can have a platform at your place that you don't have to invent every time. So if you have a platform today, like all that test and measuring equipment, like Agilent or any other company, they will have a platform. Means same type of keyboard, same kind of display, same kind of power supply, same kind of hardware. Through software, they will do the reconfiguration. So for your application.
जिओ फायला भैयानी वगैरे की त्याच्यामुळे रेंज येईना का? मला ही एअरटेल लावून दे ना, ह्याला तर रेंज येईल.
Hello, any concern? So acquire some expertise in data acquisition, ADC, DAC, DSP, wireless transmission, amplifier, power supplies, and build prototype, right? So this was one of the disruptive technology I attended at the Clio. This is flexible display, and this is a company Royal in China, and this talk is there on their website, and see that this will provide the new generation of human-machine interface. And that will transform the way, we experience and interact the world, because it will have a conformal, screen that it doesn't require any flat screen or anything. So depending on your handbag, on your refrigerator, or your microwave oven, on your, your T-shirt, everywhere, you could, it's offer, unlimited opportunities, right? It's just limited by your imagination, right? So fully flexible displays and fully flexible sensors. So if you are in the sensor, you may also like to think about a flexible sensor and integrate them, so then you become flexible technology. I would recommend each of you, attend this talk. It is recorded on the Clio website. It's a very sophisticated technologies, and I wish that India was working on it. They may also be looking for people. And by the way, the Chinese, they give very high importance to Indians. They feel that the Indians have good brain and they like to work. So you may like to think about getting a job there also. And they pay you very well, and you can learn a lot from them. Now, this is another application. If you are, for example, you are close to the borders, and this is called optical LAN. This is, for an example, I have taken the avionics platform, a jet fighter, for example. But a similar network you would see exist on any military vehicle, whether it's a submarine or a ship or any jet fighter or cargo plane or even a van. It requires all kind of functionality. So I just want to give an idea, I know what goes in there, because whatever you are working on may be needed here in one form or the other. Okay, just to give you, for example, on the top, this is a cargo plane C-17. And inside, my company used to work and I was trying to help them. This is only for the vehicle management system. Vehicle management system, you have to control, the engine and everything, the maintenance and the fuel and electrical. just for that. Look at that. It was like a huge snake farm, very weight, few tons of weight. And when it was replaced by optical fiber, the weight reduced like to just a few percent of the cable. But on a particular military platform, right? When I was a student in Pilani, half of my class ended up in the military because military only has the jobs, Air Force, Navy, and Army. And many of you might end up in the military. So the communication network. In the communication network, you have different frequency band, high frequency, VHF, UHF, L band, you have common data link, you have satellite link, and all this data you are generating, but this data has to go somewhere, and then you have to use optical fiber. The most important thing is that different sensors, you have to get the data, you have to see all the military platform, they need to have eyes and ears, right? They need to see what's happening around, right? And these are the moving vehicles, and they have to see that if your camera is not still camera, you're moving and you have to take the picture. So a lot of technology, you have the radar, you have the imaging devices, you have different cameras, and you are generating the data, huge amount of data. It has to go somewhere. So again, the optical fiber is used here. But the most important thing where you people can think about is the electronic warfare. Now, a lot of money the defense spends today is on the electronic warfare. Now, electronic warfare does not mean that there is some kind of electronic gun or anything. Electronic warfare means that you control the spectrum and you deny the use of spectrum to the enemy. You can jam their frequencies, and you only own the spectrum. And so this is called electronic attack. Electronic protection means you protect your spectrum and you attack their one, right? Electronic support. Through the communication, you support your war fighters. And here, the optics, the photonics provide a big advantage. You could have some sort of a free space optical communication, right? You could build some binoculars. And if the two soldiers, they can see each other, they can talk to one another through optical beam. Or you could have the tank, right? The tank should have an optical terminal there, and they can align two tanks, they can transmit, so they don't need any the RF spectrum there. Just for your, think about that, I'm just trying to give you an idea here that these are the different functionality, right? These are the storage. All the data you are generating, it has to be stored there, file server, right? And these are the different displays. The war fighters, the people who are sitting there, they have to take a decision. The data has to go there. So you may find today, whether it is a jet fighter or it is a commercial plane, Airbus, or a huge optical network inside there, okay? Now, this one area is of military applications, and a lot of money there. If you, this is also sort of a sensors, right? And this is where all the defense companies, JPL, or in India, I think SSPL, they all work in this area, and that is to build the detectors, for the long wavelength, near infrared, short wavelength, medium wave infrared, and all that stuff, different materials, different structures. And they are used in sensing, for industrial, scientific, military, law enforcement, and medical applications, right? And this is one area is strategically important. So here, the cost is not that important, that is expensive or less expensive, because here, you may not have access to that. If India and China are at war, you may not be able to get from them. So this is one area that you may like to dig into that and see what you can contribute, or what's going on. As I said, that I'm away from India for last 40 years. I do not know, but this is the current situation. But I know that SSPL used to work on these detectors. So anyway, this is to give you that this is one area very relevant for research and manufacturing in India. The LiDAR is another applications, right, where you can use LiDAR for, LiDAR is light detection and ranging, right, for autonomous vehicle, agriculture, river survey, modeling the pollution. So all these applications are very relevant for India. The agriculture, agri-photonics, right? You can use the photonics for monitoring, observe, and measure the crop health, increase productivity and quality, predict the future yields, make better strategic decision before going to market. As I mentioned in the beginning, 60% population relying on agriculture, but they add only 15% to GDP. Farmers are dying, they are suiciding, they don't have the cash flow. And photonics can provide a big help. $30 billion, agriculture economy in the world is like $5 trillion dollars, and R&D spending is $30 billion. And the optical component can find a sizable, part of this. So think about this. I mean, I see that quite a few universities in India working in this area, and I don't know the status, but this requires a huge investment by government of India, because farmers should also use the technology, right? Now, this is another thing, because many countries, they are running out of land. Like if you go to Japan or South Korea, or even India now, land would be a problem in future. So they are using the artificial light, right? LEDs, blue LEDs, red LEDs to grow the vegetables inside the basement, inside the attic. Red LEDs promote the root growth, and blue LEDs, they promote the chlorophyll production, the leaf growth. So this is what if you want to have, as LEDs are very inexpensive, right? You can buy the LED growth, the LEDs. So it could be a project for a master's project or an engineering project, that you have a small nursery there and see how things are, and could provide, many times, you don't have like our soldiers, they are on the glaciers, they are on the mountains, and they need fresh vegetables, they need fresh fruits there, and they could use this technology over there, right? That they can grow the fresh vegetables, they don't have to be shipped there, that you can make it anywhere, and you can use the solar power, to generate the electricity. So anyway, this is one thing that think about outside the box, that think about the need, not just for the consumers, but the money, the largest money in India today is for the defense, because we have the enemies surrounding India in all directions. And we have the war fighters, we have our troops, and they need, so this is something that could be used by military, like for example, if you have a submarine there, they could grow the vegetable inside the submarine. So new applications. Now this is another big area today, right? India must be wasting, billions of dollars of food every year because it gets spoiled. And this UV LEDs today, so normally you use mercury lamp, but mercury itself is toxic stuff. People don't want to use mercury. But if you have the LED, UV LED, and it can have much longer life, more robust, eco-friendly, right? Very little power it needs. And you could use to, disinfect the vegetables and fruits. Like this is an example from USA Department of Agriculture. Strawberries, after 8 days, you see they got spoiled, and here nothing happens. They were exposed to UV light. And actually, if you go to today, Amazon, they're selling this sanitizer for $100 plus, and you can use this. So, and this is one area, the UV light is not only for sanitization, it has multiple applications in printing, lighting, communication. The scattering of the light is, is inversely proportional to the wavelength to the power 4. So the UV light is scattered. So it's a non-line of sight. So you can, suppose you have soldiers at different places, and if you have they can talk. They don't have to align the optical beam because light gets scattered. And this is called non-line sign of communication. You say, it could be a huge application. So, and these are the different material system. You have the different frequency bands, ultraviolet, A band, B band, C band, and different materials. So this is, if you want to work in devices and materials, so this is one area. In the healthcare today, for each body part, right, there is a device, a diagnostic device. And I'm not an expert here, but this is a huge market, like $30 billion is projected in 2018. It was the actual number, and 2021 goes to like $44 billion. But for CSIO and for you people, this could be a very relevant area. SPIE, actually, they have a poster for already there are different devices in the market. If you go to any place, physical therapy, they use a laser beam for massaging, because this 980 nanometer laser beam that can go inside, and can heal the muscles where you have the pain. It can penetrate. So every every physical therapy center today have this massager. This is a success story of India, highly successful story of India. India already reached 34 gigawatt power. India has the power on the canal. Now they have the on a lake. I was visiting this National Salt Memorial in Navsari in December, and this is where Mahatma Gandhi ji started the Satyagraha movement, and I was pleasantly surprised. They have this solar trees, right? 41 solar trees, and they generate 182 kilowatt power there. This is the Dal building in Bangalore. They have these solar panel on the vertical wall. So India has a huge potential here. You people, if you have money that's sitting in the bank, put a solar system on your roof. Or advise government of India, all the highways are built. They can build the canopy, solar cells, like on Rajpath in Delhi. Have a solar cell, solar panel canopy there. All the rivers. Near Chandigarh, you have this Bhakaranagar Dam, Govind Sagar. You could generate, gigawatt power just by having the floating power station. I was glad to see that my UP government also, they're building their floating solar power station on the Rian Dam, will generate 150 megawatt power there. Now, this was all different technologies, right? So now here I will be answering some of the questions Professor Sadhana, he raised in the beginning. There is a change of industrial culture throughout the world today. In 70s, there was more emphasis on research because you had to invent the technology. They did not exist. Laser just appeared. You had to perfect this. Optical fiber was not there. Transistors, ICs were just in the early stages. So you had to move in all directions, right? So more emphasis on research. You had to figure it out, how to make omni contact, how to reduce the contact resistance, how to make the devices more reliable. So there were a number of areas, and they have been solved. And then the idea was that from research, we had to move now in design and development. So in 80s, and more efforts, equal efforts in research and development, right? But when 90s came, people figured out that, basic building blocks already exist. We already understand them. So more effort in development and design, D. But in this century, there are more efforts on I and S, that is integration and services. So many companies like IBM today, right? They provide professional services. They would maintain your computer networks. Yes. So today, many companies, they are just relying on services. They feel that would make more money, right? Mrs. Thatcher in England, she killed that industry there. She felt that, we will provide services and make more money, financial services, like Switzerland does that, So the emphasis more integration means buy the cheap parts, let the world work for them. Why to have a cow when you can buy the milk, right? So they felt that like Chinese, Indians, do the dirty work, and they will do the integration and provide services and make money, right? So today, Cisco, they don't make anything, or the companies, many companies are fabless. They don't have a crystal growth, or they don't do any fabrication. They get done in foundries. There are foundries for materials, for crystal growth, assembly and packaging. They do all that dirty work, right? So most system companies invest in our design, development, and integration centers. And this is called fusion of technology, putting together. And this outsourcing, and this is a great benefit to India. But if you want to remain in research today, then industry is not the place. You stay in academia because that's where you have freedom. Industry today, that time is gone. So if you're in academia, do good physics, and for the scientific knowledge, develop prototype to test your concept and transform science into technology. This is very important. Otherwise, your work will not go anywhere, and you will be just wasting your life, because you go to live only once. Forget about that. There's a life, next life, or if we are not done in this life, we can do in the next life. That's all bullshit. Just you have the life. This planet Earth is the heaven. We are placed at the right, place from the sun, our planet, right? We have the air, we have the water, we have everything we need. We are parked at the right place from the sun. If we were a little away, we would be too cold. If we were too close, we would be too hot. With the right amount of the weight. Otherwise, if the earth was lighter, then it won't be able to hold the air. The nature is purifying. So we are living in heaven today. So decide really what you want to do, but make an impact. Do something good, right? Heaven and end application and customer in mind. That's a big plus. So the major driving force today, Sadhanaji, this is one answer to your question, what is happening in that. The major driving force is the cost, low cost, low cost, low cost, low cost. And that's where the India is missing. Our productivity is low. People are more worried about useless stuff, religion and caste and all kind of stuff. You see that here. Chinese are beating us here. They focus only reducing the cost, get the cost out of this. But today, if you want to do research, you want to do something, these two lines here are most important. The swap. All the military, they put a lot of funding there to reduce the swap, that is, reduce the size, weight, and power. Think about a soldier carry a radio. The radio, you may not realize that many of you may not be even lift the radio. They're so heavy, 50, 60 kilograms with the weight, and that provide only a few kilobits per second. So if you can come out with anything where you can reduce the weight, size, power, you can end up with some funding. Quality of experience. You are willing to pay $1,000 for a smartphone, iPhone, right? Why? Quality of experience, and they keep every time 2 years you upgrade your phone, you buy another phone. Why? Because you feel that there are more friendly human interfaces. So it's all because of the quality of experience. So whatever you do, think about that. How can it provide the interface, quality of service, design, development, manufacturing, marketing across the globe today? People don't care. Where do you manufacture? They want to reduce their cost. So somebody asked me the question, how come India is not making the solar panel? I think that's where the problem is, that because Chinese are supplying the panels at low cost and better quality. So Indian manufacturers are not able to jump into that. Shorter product development and lifetime cycle, global competition. So until 70s, Indian industry was protected. There was a custom duty, there were the import tariffs, and that was protecting, and those protection have gone. So industries are becoming bankrupt. People feel that, hey, we can buy the things and resell it. So on the other hand, we have so much manpower. A company is set up in Calcutta. They want to make the LEDs, lighting, and they say that we have a long way to go in India. In China, you can fill a big football stadium with technocrats. While in India, we can't even fill a small room. And that's where we are lacking. So think about that. That means that we have more theoreticians. We create more, people who like to be babus, rather than make things work. So he said that this guy, it appeared in this magazine that if we had to roll out production capacity in China, the manufacturing would have started as early as fourth day itself, where it took them about a year in India just to train the technicians. So barrier and limitations to reduce the cost of photonics chips. Here are the different things I listed here. The device size in photonics does not scale. In the case of silicon, when you have the electronic device, it scale. If you reduce the dimensions, everything scales. The power requirement goes down. You can integrate more devices. But in silicon, you replicate the same cell again and again. And the devices, they all are identical, right? In the case of photonics, if you have a source or detector, you need minimum volume, because if you have more volume, you get more photons out. If you have more volume, you can detect more photons. So they don't scale. You can't make it very tiny. Photonics is a 4-particle device. You have electrons and holes. They recombine to generate photons, or a photon generates electron holes. And you have heat, which is the quanta of heat is photons. So you have 4-particle devices. You have to couple the optical power. And the photonics, you need 3-5 direct band semiconductors if you want to make efficient sources and detectors. And these wafers are fragile. The size of the wafer is limited to, to 2 inch, 3 inch, 4 inch, or gallium arsenide 6 inch, whereas silicon you can have 12 inches. 3-5, you need to have 50% group 3, 50% group 5 atoms. If there is a slight difference, and that causes the stoichiometric defects. Volt electron is just 1.3 nanometer. That's why you use, electron microscope or transmission electron microscope. You can have high resolution, right? So today, 7 nanometer CMOS technology, you can have more than 100 transistors, which can be packed on every 1 micrometer square area of chip. So you can imagine, integrate billions of transistors on 1 millimeter or 1 millimeter size of chip. Whereas just for a laser, for ease of handling and all that, you need at least quarter millimeter by quarter millimeter chip size. So in this area, you can make only 16 lasers or 16 detectors. On the other hand, photon is very fat. You might think that a photon is nothing compared to electron, but photon is very fat. 1 electron volt photon has 1,000 times larger wavelength, 1.24 micron. And so you can't make any component which has a dimension is smaller than that. So you can see that where you can have more than 100 devices, here you cannot have one device. A typical passive components can't be made much smaller than the wavelength of light. It's a physics problem. So Moore's law doesn't apply here. So it will be very expensive to replace transistors with lower functioning photonic modulators. Okay. So due to the physics and economics, it makes no sense to merge photonics and electronics, monolithic integration on silicon. So this is just a wishful thinking. But people are fooling, they okay, we will do this, we will do that, and get a lot of money, but that won't happen. So the solution is photonics on one wafer, electronics on another wafer, and then house them, together in one package. That's more realistic. Most of the cost of a photonic device is in packaging. The wafer, because you may have the large, on one 2-inch indium phosphide wafer, you can make 10,000 lasers on that. In 4-inch indium phosphide wafer, you can make 40,000 lasers on that. So, and each transmitter receiver only use one laser or one detector. So that's not a major limitation. So you have chip level here devices, and then you have to put them on a carrier, and then carrier go in the housing, and this housing you put a lid on them, or you make a transceiver. So these are the different packaging technology, and this is very sophisticated. And China is very good in that, because those people, Chinese can do things very well. If they have to reproduce, they have to do the same thing again and again, right? They don't mind. But India, many people say is very boring. There's nothing interesting. But Chinese, they feel that they are doing something and they can do extremely well. So the packaging requires reduce their footprint, simplify electronics, reduce number of components, optimize power dissipation, avoid crosstalk, simplify packaging, scalability, repeatability, power efficiency, volume production. So these are the different things which are important to reduce the cost. Now, some specific challenges to India and their mitigation. So Sardanaji posed some questions. He maybe answer to some of those questions. So the problem India faces is that lack of technology and facilities awareness. Like, for example, India today has quite a few center of excellence, the centralized nanofabrication facilities, but people are not aware. They don't talk, they don't go there, or they will complain that, oh, we don't have this, we don't have this, we don't have that. So the funding is an issue. Some people get the funding without even asking. The funding people, oh, sir, do you need any money? And some people starve. They keep asking, but they get nothing. Infrastructure is not there. Culture for product development is not there. It's missing, Experimental facilities and their maintenance in universities, I think, are lacking. You can buy expensive equipment, but how to maintain it? Like, suppose you have any system which require a vacuum pump. The vacuum pump maintenance itself is a big problem, It may require liquid nitrogen, it may require compressor, it may require replacing the compressor, liquid helium, it require liquid nitrogen, may require purified hydrogen gases, nitrogen gases, and the ownership. What happened that I was visiting one lab, they had an MB machine, and I found there are 8 people managing one MB machine there, whereas I myself in Ballag was managing 2 MB machine. And turned out that there are 8 people on that MB machine, and everybody had some kind of director, assistant director, deputy director, additional director, director, senior director, executive director. So once you have the title of a director, then people think that they are not supposed to go to the lab. They don't have to work. Somebody else will do the dirty work, right? So, but here in US, in Bell Laboratories, even our vice president used to have his own lab, own technicians. He may not go to the lab, doesn't have time, but he would have postdoc and they will do the work. So the idea is the ownership. You own it, and your life depends on that. Every year you go to show, what did you do this year? You have to I say that I did this 2 years ago, 4 years ago, that is a history. That has no value. What did you do this year? Why do we need you this year? So the collaboration and networking is lacking in India. And I think this, we set up this Prakash Bharati and these talks, I think this would address this issue, because now you are able to connect anybody from anywhere in the world, or India can join. Industry university partnership is lacking. And I think you people are doing the right thing, that you have industry and university. I think you are addressing the problem. You are hitting right on the head of the nail. I really appreciate that. And in India, the businesses, there's a lack of trust. The people feel that the businessman is a thief. Chor hai wo, so this is one problem. Our businessman is still, the taxes and all that. So in other countries, businessman is respected. And India, I find that there's no urgency also. People say, oh, don't take stress. इस जन्म में नहीं हुआ तो अगले जन्म में हो जाएगा. There's no hurry, or just सब चलता है. Oh, don't worry about it. There are other people who will take care of. So this चलता है mentality, I think, is hurting. There is a misuse of funding. Some people have the funding and they end up buying the wrong equipment. There's a more interest in journey than the destination and results. So we tend to complain more. We tend to say we don't have this, we don't have that. And if you tell them, oh, you can go this, you have that there, right? The facility may be sitting next door. It's just that you don't want to talk. People look for reasons for not doing things. And there's too much politics, mostly theoretical, teaching and research, not many industries. So these are the kind of issues which I feel that are hurting us in India. The mitigation plan is that realize yourself, true self, who you are, You be the change you want to see. That's what Mahatma Gandhi used to see. You be assertive. If you have a problem, point it out. Don't be afraid of. Take ownership. But if you are assertive, you want to point out, then you have to be, do in such a way that you don't annoy people. You have to do in a polite way and the right way. Explore local, national, international collaborations. Find partners where you could do experimental work. I learned I have spent, last 35 years in industry, but all I did was experimental work. If I do theoretical work, I don't get it. I forget it. Or to me, anything I want to work, I want to see how can I make it to a product? How can I make a prototype? How can I demonstrate this? So that's where my mind works. One thing that you should do that, visit expos. If there is an expo, if you are visiting Delhi, see that if there is anything going on in Pragati Maidan, go and visit there, meet people, see what are the products, what are the things there, talk to them. They may have jobs for you. They may appoint you as a manager. They may appoint you as the CEO of the company. Talk to them, what's happening. But at the same time, you should have a balance in life. Try to work on more than one project. One may be long-term, one short-term, so that you address the need of everything. Be your own boss and compete with yourself. Try to do better than what you did yesterday. Have a balance. I mentioned that. Work on near-term and long-term projects. Think outside the box, but have industry involvement. If you are working there, these talks are not enough, by the way, because there was a film called Upkar in 60s, 67, and in that case, Pran tells Manoj, Manoj's name was Bharat, राशन पे भाषण बहुत हैं लेकिन भाषण पे राशन नहीं है. So these talks are good, but they don't bring any results, So you need to really have industry involvement. So in your research institution, in your universities, you should have some sort of an advisory board, maybe just for namesake, for decoration purposes. It gives importance to other people, and have an advisor from the industry, and have once or twice meeting and some good lunch or dinner there, and tell them what you are doing and seek their advice, seek their input, what you should be doing, So invite them, have them part of yourself. And that's how people work here. I have been in two advisory boards in Georgia Tech and Institute of Technology. And I know how they work there. They invite people there. And though we don't have any control what they do, they don't do. But we are in the advisory board. I ran an election here. I'm in the Board of Education in my town, and I'm there. So I don't run the school system, but we are in the advisory board, and the school system, they get the feedback from others. So try to involve that. Now, this is another change, the hardware, software, firmware, glueware, what is hardware, it continues to get smaller, better, and cheaper, lighter. And this is a challenge for India. Software is getting bigger, more complex, expensive. And this big advantage and global opportunity for India. In a big project, as the project matures, 50% cost is hardware, 85% cost is software. So today you want to buy a system from Agilent, for example, a oscilloscope or a synthesizer. You may find that you can change a oscilloscope to a spectrum analyzer by changing the software. And software also, they would give you a license and make money out of that. So the world is moving towards software-defined reconfigurable system, but through software you can change it, right? So like your phone, your smartphone, it has how many radios? You can count them, 4 or 5 radios, right? It's GPS, it's a Bluetooth, it's a 3G, 2G, 4G, right? It has Wi-Fi. So you have multiple radios. They operate different frequencies, different modulations, and all that stuff, right? And it can recognize by itself, which network is available. Through software, you can change the system. The Geo network, right? Geo providing you service at lower cost. Why? They bought the white boxes from Samsung, and they have the software engineer at their place. So they write their own software, right? So this is called software-defined network. Often products fail due to software, and the glueware makes the system work. So if you are in the school, consider having a solid background of both hardware and software, both theoretical and experimental. Think of a big picture, end user in your mind, and application. How will it work? How will you bring power here? How will you get the data out? How will it connect that? All these things are very important. Build prototype. Attend courses on system engineering and project management is available, right? If you want to set up on your own industry, and Punjab is very good, you can admire Punjab, in entrepreneurship. Digital India has millions of programs and problems, right? And so are the opportunities, and technology can address them. But you have to crack inside. It has to come from inside you, right? It's like an egg. If you crack egg from inside, you can get a beautiful life outside, right? But if somebody has to crack you from outside, if your advisor, your supervisor, your boss has to tell you what to do, then you are just food for somebody, right? You are just omelette, right? You are working at somebody else's wishes. So it has to come inside you. You must be self-driven, go and get that person. So as I mentioned, invite business, industry, defense, and city leaders to learn about their needs and wants. Look for what the society needs and then try to invent it. Visit expos, find better ways of doing existing things, right? Reduce the size, weight, power, or cost. Do brainstorm sessions in group, come out of the idea like you are having this meeting. Have a meeting between yourself. Come out, take a project, take things that, So you people yourself come out with, become a leader on a rotation basis, right? So the subject could leader one time, and you could be leader second time. Have a meeting and record the minutes and prepare a quad chart, support documents, and think, approach who might have value of your idea, request for funding. Develop concepts, prototypes as part of your classroom projects. If for the source of technology, your R&D, your collaboration, your CSIR lab, provide clarity when none exists and create energy. Need to work under resource constraint space, right? Most of the companies, big companies, they grew up out of their garage, right? They did not have the resources. They did that. So think about today, big companies like Amazon, Uber, Facebook, Netflix, Alibaba, bed and breakfast, right? Amazon doesn't have any manufacturing, but you can buy anything in the world from them. Uber doesn't own any single taxi, but they have the largest taxi network, right? Facebook does not produce any content, right? But you have largest content, right? Netflix does not own any theater, but they provide the maximum number of films, right? Alibaba does not own any industry, but you can buy anything from them. Bed and breakfast, they don't own any hotel, but they control largest networks. Think about that. That something you can come out, right, which doesn't require resources, but you can create a lot of wealth in your village, in your town. You can have through internet auction house. People can trade their cattle, their crop, all that stuff, right? You have to select your career extremely carefully, right, and change it necessary. Enjoy what you do for living. Then you will never have to work, right? When work is a pleasure, life is a joy. On the left side is the Sunita Williams. She's my hero, where you think about her. She, in this COVID environment, she has given lectures that how they lived in a space shuttle, right, for 9 months, 10 months. She is the one person who spent the maximum time in space. NASA loves her. Her quotes are widely circulated, So watch people around you. People play multiple roles. Ask them which role they like. You ask where you want to be after 5 years. Consider your personal values and circumstances. The more you plan your career, the better you can face unplanned crises, right? We are the authors of our actions, but the results are subject to the hidden law of nature. That's the karma yoga. If somebody tells you, oh, you do your karma, do your work, and don't worry about results, that bullshit. We all need results. But remember that results are subject to the hidden law of nature. Like this COVID-19, it was not planned. Nobody asked for it, but it came. Can't help it, right? But the other thing is that the Douglas Adams, this is good for me. I rarely end up where I was intending to go, but often ended up somewhere that I needed to be. So if you do things with the right mind, right outlook, right attitude, sometimes the nature knows what is good for you, will take you there. I come from a village, I never thought that I never even sat in a train until I did my MSc. I never thought that, I could get a job in a bank or a high school teaching job. I would be quite happy. So, but, I ended up where I am today. I never thought about that I could even visit Bell Laboratories, or I could do this or that, or I come to America. To me, visiting Delhi was a big thing. So, but the nature, knows what is good for me. So trust yourself. Do the things with the right attitude, and the nature will take you, what is good for you. But the most important thing in the life is find a mentor. This mentor thing is very important. Remember that we are born divine, but ignorant, and we need a teacher. And somebody asks you what the difference between Eastern culture, Western culture. This is the biggest difference. The Western people would believe that they are born sinners and they need the Lord, for their salvation. We believe we are born divine. Divine is our default nature, but we are born ignorant and we need a teacher. And that's where you need a mentor. A mentor listens and gives advice and objective feedback to you, right? With your interest at heart. Help you at the time of distress, identify your internal strengths, weaknesses, opportunities, and threats. One in your organization teaches corporate culture and valuable, career moves. So do not think, oh, I don't need anybody. I know what it is at. Just ask people, but apply your own strategic filters, right? So you don't have to take anything. It's a two-way street. Your mentor helps you and you help the mentor, right? I learned from my grandkids. So this is called reverse mentoring, right? A good mentor can change a donkey to a horse, right? It provides you, the food to your brain. So in Bhagavad Gita, Krishna and Arjuna were together for a long time. Krishna never revealed the knowledge to Arjuna. He did only when Arjuna asked. So you have to ask if you don't know. You cannot think that, oh, you didn't tell me that. Oh, you knew that I was going through this problem. People make you guilty. You could have told me. You knew that. You have to ask. Asking is very important. If you're looking for something, don't assume that other person knows that they will help you. Ask and prepare to listen no, gracefully. But person may have, if somebody says no, oh, thank you very much, I understand your situation, we'll get back. Don't make enemies, right? Because person said no. A lot of people will say, oh, I cannot ask. Because if this person says no, I can't take it. Why can't you take it? What's the big problem? The person may have problem, so that's what I'm trying to say. Ask. You have to ask if you do not know. But I don't know if you know that Hanumanji, he's the commander-in-chief of Sri Ram's army. He could do anything. He could fly, right? Your fear will go away just by, chanting his name or reading the Hanuman Chalisa. But do you know that he had a curse? And the curse was that he would forget his strength or his capability. Somebody has to remind him. Sugriv has to tell me, hey, you can fly, you can do this, you can do that, right? We all have that curse. We do not know our strength. We don't know our hidden strengths. And that's what you have to recognize and realize your hidden strength and inspire others to find theirs. This is what I'm doing during this talk, inspiring you. making you feel that you can do anything you like. You are the best. You are second to none. Indian brain are respected all over the world. You can do anything. So go an extra mile. In India, I find that people go all the way, but leave the last mile. Oh, usko baad mein kar lenge, abhi kya jaldi hai, and then that thing never happened, and that thing never finished, right? They will buy an expensive machine. Oh, ye cheez to hum ye nut bolt to yahi kharid lenge. Lekin wo nut bolt, getting the right nut and bolt itself is a project. Finding the right screw is a project. The different kind of threads are used, different kind of sides are used. So they are little things, right? But always try to be part of a solution, not the problem. And go and get type person. Now, key for the lifetime employability. So I mentioned find a mentor. Behave less like an employee, behave more like an owner. Dedicate yourself to creating, selling, deliver values. View your employee, your customer. Invest heavily in core skill technology, develop soft skills, refine your communication, build self-managed, self-reliant, work on winning projects, but develop teamwork. Teamwork is very important. You could be the gold medalist, or you could be anything. If you cannot work with the team, nobody would hire you. Or if they hire you, they would kick you out, right? You have to be a team player and be ready for disruption. Nothing is meant for lasting ever. Everything is subject to change. You have digitization, urban Uberization, you have globalization, you have outsourcing, merger, acquisition, restructuring, downsizing. So these are things, but you should have some core values: trust, honesty, and respect. These are the priceless core values. Take a lesson from a tree, stand tall and proud, be content with your natural beauty, drink plenty of water, remember your roots, and be useful to the society by offering whatever you can. Beautify your surroundings, enjoy it, and view your true nature. And to summarize, this 21st century belongs to photons, like 20th century belongs to electrons. Artificial intelligence, broadband access network will change the world and lead to the fourth industrial revolution to success. Photonics offer unprecedented opportunities and challenges. Read tutorials, articles in IEEE journals, magazine, newsletter, technology trends, and keep yourself up to date. Pursue every opportunity to gain first-hand practical experience. Attend conferences, trade shows, job fairs, expos. Build network of friends and well-wishers. If you are in the wrong field, change it. Position yourself to build a successful, enjoyable career in digital India, smart skill India. Don't hold onto a familiar pain. Consider trading with the unfamiliar pleasure, okay? That's all I have, Jai Hind and Jai Fonon, and good luck. Thank you for listening to me. It turned out to be quite long, but that's all I have.
Yeah, thank you very much, sir, for a very motivational talk, sir. So there are a couple of questions in the chat box window, so we can take them quickly.
Sure.
Yes, sir. So I shall read them for you. So the first question is from Niranjan, sir. He's asking, he's asking that there is an academia-industry relationship is missing in India. Many Indian universities still lack research infrastructure. That's why researchers in India universities just manage to compile their thesis for degree by just managing the relationship. So could you comment on this?
Yes, I mean, I already commented on that in my talk, that this is the real problem. And but you have to find a solution. You are doing the right thing, like you are doing initiative. This is a unique initiative you have taken. I already mentioned that you have to trust industry. You have to invite industry people in your advisory board, form an advisory board, invite them like you are doing this, but have a sincerity, invite them, show them what you are missing, and then you will find the relationship would exist, right? And if you don't invite them and you feel that the industry will come to you, they will not come to you. They will feel that it is a waste of time, right? But if you give them credit, sir, you please come and we would like to have a meeting with your advisory board. We are looking for directions. If you want to make friends, you seek advice. Anyone. So you have to start somewhere, right? The infrastructure, but I find that government of India has made a lot of investment. We were discussing last few days, right? You must have seen on Prakash Bharati. There are, nanofabrication facility. I see Bangalore, in IIT Bombay, in Jaipur. There's a facility for testing and characterization. If you make devices, you find that every IIT has transmission electron microscope and other equipment. They may be in the metallurgy department, in chemical engineering department, different places. So people really have to work on their own. What I find that we are more individualistic. We don't like to share the credit. We feel that somebody will steal my stuff, right? But that mentality has to go because those time is gone, right? You have to work together, have relationship. And if you want to work together, find out where the help is, like you people are there in CSIO, take your friends, go for lunch and discuss the issue. In Bell Labs, what we used to do, we used to go for lunch together and somebody say, I have this problem. Other person, oh, I have this, I can do this, I can do that. So you add everyone. So don't talk garbage, don't talk about religion, don't talk about this, don't talk about that. Think about what you can do together. And invite industry people. Many times you can have somebody from industry for the evening session, physical session, have lunch, dinner, and then you will get a lot of things. So you are taking the right. First time I see that somebody has taken initiative, though I don't have much experience, It is only recently that I started interacting with India, So it's good that you people are doing. And other thing is that I see that a lot of talks, you invite people from outside, but I would like to see research scholars like yourself give talk. You people should form your student form network, what you people are doing. And I find that I go to any conference, they don't put any local student, research scholar, give you a talk. They put them in the posters on a large scale and invite outside people to give talk, right? Sometimes useless talk, which are no relevance to India. So the youth like yourself should get more involvement, right? And the problem which you are experiencing, if you write a white paper, write something, I can help you. I can put them together, approach the right places, but come out with a solution. I mean, you are in India, you know what's the problem there. If you identify the problem, 80% problem is solved.
Okay, thank you, sir. So going to our next question. Niranjan sir is asking how Indian researchers in India can increase faith in industrialists so that we can excel from India by exporting good quality products to worldwide.
The point is that it's a two-way traffic, right? If you bring some value to them, then they would trust you and you would trust them. So let me give you some example. When I was working for Government of India and I used to work with the research labs, transferring the technology and industry. So the research scientist, for example, I was working with CD Pilani and NPL. And CD Pilani has a technology for transistor header, TO18. And NPL has the technology for a ceramic pickup, which used like record player. But anyway, the point I'm making is that the scientists expected a red carpet treatment by industry. They felt that the industry, when they invite a foreign engineer, they give that red carpet treatment. And they don't extend the same treatment to them. They expected from the industry a red carpet treatment, but the industry thought that these are the local scientists and they treated them like the local people. So the thing is that if we don't worry about those things, when I joined Bell Labs, I was told by my hiring manager that if people cannot reproduce your results, if people cannot make use of your technology, it is useless. So just 1 second. So the point is that if you don't care about the credit and you are interested in the end results, there would be a lot of trust and respect. Trust is the most important. The trust, one word, trust, is something that I feel that should be a course itself, because of lack of trust, there are problems between spouses, there are problems between parents and children, there are problems between the countries. Lack of trust is the problem. So you have to have trust, and you have to deliver values, right? So don't worry about credit. Don't worry about somebody is buying you some good food. Don't worry about somebody is treating you this and that. Idea is that your product, your technology is your baby, and you would like your baby to grow, right? Just think about your children. Your parents would like to see that my children, they are successful in life. They don't care if the children take care of them or not. They care that children themselves should grow. So whatever you do, you think about that, you should find a place. So like wireless, our life today depends on wireless, right? So Marconi got the Nobel Prize. But Marconi's invention of this wireless transmission would not have happened if Sir J.C. Bose, gravitational Bose detector, was not there. He provided a detector. He came to the Royal Academy in the England and he presented his work. And Marconi used a detector. So Marconi, Nobel Prize should have gone to J.C. Bose also. But he was asked and he said, oh, invention is more important than not the inventor. So what I'm trying to say that we should have some humility, we should be trying to see that things happen, technology goes somewhere, and ask industry. As I said that I'm not there, you ask, hey, tell us what the problem, how can we do better, right? You don't find fault in them. Hey, tell us we are having this technology, what we can do for you, approach them. And like, for example, in Chandigarh, and there's a company called CDIL, Container Device India Limited, is they're in semiconductors. Invite them. Hey, we have this sensor. We want to do this thing, and what we can do so that you could use it, make a product. So it's a bidirectional road, and conversation has to start from somewhere. And I think you are taking a right approach. Any other question?
Yes, sir. There is one more question that we can take. So that question is Dr. S.K. Pandyan, sir. So he's asking, can you please tell us about SpaceX plan to build up rockets and spacecraft to deploy the world's most advanced broadband internet system? So will it be a challenge for Photonics, especially in communication?
Could you repeat the question?
Yeah, so the question is, can you please tell about the SpaceX plan to build up rockets and spacecraft to deploy the world's most advanced broadband internet system? So will this be a challenge for Photonics?
I got it. No, it is not a challenge. It's a that particular technology is very expensive. The bandwidth is very limited. So that is meant for emergency need, right? That is meant for, like, if you are in the plane, you can have a discussion inside, you can have a connectivity inside the plane. You are on a beach, you can have connectivity, where there's no network there. So they complement each other. So if you want to use a phone using that technology, it may cost you a few dollars per minute. So you can't, the bandwidth requirement, is very, very limited. We can provide you a few gigabit per second, right? Whereas if optical fiber, is 40, 50 terabit one optical fiber. So there is no comparison. They're totally different. That is just like, that you have the something you are doing with iron and you have the platinum. So that consider that's kind of platinum. Not everybody can afford. Not everybody can use it. So there is no threat, and no. By the way, they will also use optical fiber because they would have a base station, and base station will be connected to the optical fiber. So it is only the last mile connectivity. The wireless network is not a threat to the wired network. They go together.
Okay. So as we are running short of time, so we'll take up these many questions only from the chat box. If anyone want to directly have a direct interaction, so anyone can mute yourself and we can take up one or two interactions. If anyone want to directly interact with sir, so they can unmute their mic and we can take up one or two interactions fast, quickly.